b minus a divided by n is given by h. Okay, this is very important. This will be tending to a 0 as n tending to a infinity. You can put the values of x as a plus h, a plus 2h, a plus n minus 1 into h. 1 plus 2 plus 3 plus etc. plus n minus 1 is given by n into n minus 1 divided by 2. If you take a common factor of h, what it will happen? 1, 2, 3, 4 up to n minus 1. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learnt many problems on indefinite integral. In today's session, dear students, we are going to have session number 17 here and chapter number 7 called integrals. And what are all the topics we are going to study under this session is nothing but a definite integral. That means what do you mean by a definite integral? And then a definite integral as the limit of a sum. That means in this session, we are going to have only these two more topics, and then based on this definite integral of a limit of a sum, we are going to solve problems, dears. Now here we'll be moving on to the definition of a definite integral. It is a definite integral denoted by integral of a to b f of x dx. This is very important. Here a is going to be known as the lower limit and b is going to be known as the upper limit of the given integral function. And then dear students, if you want to find out the value of the definite integral, then you are going to have it as integral of a to b f of x dx. Suppose if you are getting f of x dx is nothing but a capital letter, let me consider the answer you are going to get it as f of x itself. So because based on the given question you are going to get the answer. Here I have considered f of x, so therefore you are going to take the answer will be let it be f of x. Then how to apply the limit here? So from a to b, first you are going to apply the upper limit which is called f of b. Wherever x is there, substitute b, minus, in between minus sign will come, and then apply the lower limit. I hope you are getting, right? So that is going to be known as the integral of, what is that? You are going to have the values between closed interval a and b. Understood? Next we will be moving on to definite integral as a limit of a sum. Dear students, what is the formula it is given by? This formula, if you remember, you can solve this problem, and this type of problems will be asked for in your examination for 3 marker. Okay? So here we will be moving on to integral a to b f of x dx is given by b minus a into limit as n tends to infinity 1 by n f of a plus f of a plus h plus etc. plus f of a plus n minus 1 into h. Dears, b minus a divided by n is given by h. Okay, this is very important. This will be tending to a 0 as n tending to a infinity. Okay, otherwise for reference we are going to write it as, or you can also write it as, if you cross multiply, nh will be is equal to b minus a. Understood? So this is very important, dears. Now, without any delay, let us move on to solving the problems based on this a definite integral of a limit of a sum, dears. Now, first problem they have asked like this: definite integral as a limit of a sum, integral a to b x into dx. Dears, here they have given f of x is nothing but x. So, therefore, let me write down the formula first. What is the formula? Integral of a to b f of x into dx is equal to, you can have, which will be implying that limit as n tends to infinity, h will be tending to a 0. Little I am going to do the variation in the formula, that's it, this one. Limit as n tends to infinity, h tends to a 0. See, b minus a divided by n, I am going to substitute it as h. So, h into f of a plus f of a plus h plus f of a plus 2h, f of a plus 2h plus etc. plus f of a plus n minus 1 into h. Okay? This is how you are going to write the formula first, and then what is the step 1 you are going to follow, dears? Step 1 is like this. Step 1, put values of x is equal to a, comma a plus h, comma a plus 2h, comma a plus n minus 1 into h. Okay. This is how you are going to substitute. So here x is equal to a plus h, a plus 2h. Now second step is what? Finding what is f of x. F of x is nothing but this one. See, f of x into dx. F of x is x only. So therefore, finding step 2, you are going to write what is f of x is given. F of x is given as x. Now, after finding out, step 3 is putting the values of x there. Okay. So therefore, what happens? This is a step 3. You can put the values of x as a plus h, a plus 2h, a plus n minus 1 into h. So f of a, see, x a means here also x a only, f of a plus h. F of a plus h means here also a plus h only, correct? Because x only is there. F of a plus 2h is a plus 2h only. Similarly, etc. F of a plus n minus 1 into h is a plus n minus 1 into h only. Understood? So this is what you are going to write as a step 3. Then what is a step 4, madam? Step 4 is nothing but you are going to substitute in the formula. So what is the formula? This is what the formula. Substitute f of a, substitute f of a plus h, substitute f of a plus 2h, substitute f of a plus n minus 1 into h. So that is a step 4. You can have step 4 is equal to limit as n tends to infinity, h will be tending to a 0, h into f of a is nothing but a, f of a plus h is nothing but a plus h only, f of a plus 2h is a plus 2h only, plus etc. plus f of a plus n minus 1 into h is a plus n minus 1 into h only. I hope you got this step, dearest. Now, next we will be moving on to simplifying this. How to simplify? See, a. How many terms of a are there? Up to n terms of a you are having. So therefore, let me write that one, which implies you can have integral of a to b. F of x dx is nothing but what? X into dx. Now which implies that you are going to have, so limit as n tends to infinity, h tending to a 0, you are getting h into n times of a, again plus, see, you can see here, observe, see how many? h plus 2h plus n minus 1 into h. If you bring common, if you take a common factor of h, what it will happen? 1, 2, 3, 4 up to n minus 1. So therefore, you can take h as a common factor. Remaining is 1 plus 2 plus 3 plus etc. plus n minus 1, isn't it? Now close the bracket. Close this bracket because you are having limit of this one. Now what I am going to do is, see here, this. Please do remember this, dear students. 1 plus 2 plus 3 plus etc. according to the mathematical induction you have studied in your first year. Let me remember you the proof. 1 plus 2 plus 3 plus etc. plus n minus 1 is given by n into n minus 1 divided by 2. Understood? Now, you are going to get it as limit as n tends to infinity, h tends to 0. This I am going to substitute n into n minus 1 divided by 2, which happens limit as n tends to a infinity, h tending to a 0, h into na plus h into, that I am going to write it as n into n minus 1 divided by 2. I hope you are getting this one. Now, multiplying this h inside, dear students. Are you getting? Multiplying that h here. So, what happens? Limit as n tends to a infinity, h tending to a 0, you are getting nha plus h, isn't it? h into n minus 1 divided by 2. Okay. Now here, limit as n tends to a infinity, h tending to a 0, nh into a plus, here see one h I am going to clubbing with this nh, another h I am going to multiply inside. So what happens? nh, one more h I am going to multiply inside, which will become nh minus h. I hope you understood this one. Divided by 2. Okay. Now, you are going to take it as what is nh. See, nh is nothing but you are having, you know already by the formula, h will be is equal to b minus a divided by n, implies that if you shift n to this side, what happens? nh will be is equal to b minus a, isn't it? Now, taking that nh is equals to b minus a, you are going to get it as, see, this nh, I am going to substitute it as b minus a. And then, after substituting, what happens? So, which will be limit as n tending to a infinity, h tending to a 0, you are going to get it as nh is nothing but b minus a. Let me substitute that, b minus a into a plus nh is nothing but b minus a, again in the bracket b minus a minus h divided by 2, right? Now here, limit as n tends to infinity gone, you are going to take it as, because I already substituted nh as b minus a. Now, limit as h tending to a 0 means putting h is equals to a 0. That is what you are going to have. Step, what is that? 4, okay? So, step 4, you can consider this only step 4. See, step 4 is nothing but substituting b minus a as nh, okay? Step 5 is substituting, put h is equals to 0. If you put x is equal to 0, you are getting limit as h tending to a 0, b minus a into a plus b minus a into b minus a minus 0 divided by 2. Okay, now which will happen? So, b minus a into a is nothing but b minus a, let me write down that, into a plus b minus a into b minus a divided by 2. Now, b minus a if you take common, see, b minus a you can take common, which will be b minus a, which implies that common factor remaining is a plus one more b minus a divided by 2. Now, taking here b minus a and LCM is 2, 2a plus b minus a divided by 2, otherwise b minus a divided by 2, so this 2 will come outside, 2a minus a is nothing but plus a, which is nothing but a plus b, isn't it? A plus b or b plus a, b minus a into b plus a is b squared minus a squared, which is in the form of a plus b into a minus b, here b minus a into b plus a. So, which can be written as, which implies the answer will be b squared minus a squared divided by 2 is your final answer you are going to get after applying the limit as h tending to a 0 and substituting the value nh is equal to b minus a. I hope you got this one, dear students. How easier, right? Now, we'll be moving on to the next problem, dears. Okay? Now, what they've asked? Integrate 0 to 5 x plus 1 into dx as a limit of a sum. Now, here all the problems I'm doing as a limit of a sum, and this is the exercise 7.8 I'm solving, dears. Now, here what they've asked, f of x is nothing but x plus 1. First, let me write down the formula. Integral a to b f of x into dx is nothing but limit as n tends to a infinity, h tending to a 0, h into f of a plus h plus etc. plus f of a plus n minus 1 into h. Okay. Now, here you are going to get it as, which implies, let me write the step 1. Step 1 is nothing but put x is equals to a plus h, etc. a plus n minus 1 into h, right? Now, second step is nothing but what? Step 2, substituting the value in f of x. So, f of x, they have given it as what? X plus 1. So, x plus 1. Now, substituting the value, you are going to get it as f of a is nothing but a plus 1. Similarly, f of a plus h is nothing but substituting wherever x is there, a plus h. So, therefore, a plus h plus 1. Similarly, you are getting f of a plus n minus 1 into h is nothing but a plus n minus 1 into h plus 1. Okay, I hope you understood that. Now, substituting these values in the formula. So, what happens? Which will be given, that is a step 3 we can take. I am avoiding one step here because you know how to write down now. So, limit as n tends to a infinity, h tending to a 0. So, h into f of a is a plus 1 plus Okay, f of a plus h is a plus h plus 1 plus etc. plus f of a plus n minus 1 into h is a plus n minus 1 into h plus 1. I hope you understood this one. Now here, how many terms of a you are having? A up to n terms. So again you are going to have, see, 1, 1, 1, up to how many terms you are going to have? N terms of 1 you are going to have it as. So therefore, writing 1 as n terms and writing a as n terms, you are going to get it as limit as n tends to a infinity, h tending to a 0, h into n times of a plus 1 times of n, okay, or n times of 1 plus, again taking common factor as h, here remaining is 1 plus 2, 2h plus etc. plus n minus 1 into h. H already we have taken common, so closing the bracket. Now what happens? Writing this one as it is, so which implies that a to b you are going to take it as 0 to 5. So a will become 0, b will become 5. So what happens there? I am writing here h is equal to b minus a divided by n, or nh is equal to b minus a. So here b minus a is nothing but you can have nh is equal to b is 5 minus 0, which will be 5, isn't it? So nh you can substitute as 5, and then dear students, here you can substitute as a is nothing but what? A is nothing but 0, isn't it? So therefore, by substituting a as 0, here it will become 0 into anything will be 0. So neglecting that value, x plus 1 into dx. Now which happens, see here, limit as n tends to a infinity, h tending to a 0, you can have h into n times of a, it will become 0, plus n you are having, plus h into, you know already, this is nothing but, as in the last case I have written, it is n into n minus 1 divided by 2. So therefore, substituting that, n into n minus 1 divided by 2. Close the bracket. Now you can have 0 plus anything will be the same thing. Multiply h inside, which happens limit as n tends to a infinity, h tending to a 0, h into 0 is 0 only. So neglecting that, nh plus hh into n minus 1 divided by 2. I hope you are getting this one. Now which happens, now I am going to neglect n because nh I have substituted as limit h tending to a 0. That is what? This is a step. Here I have taken 4, right? Now this is a step 5. What is a step 5? Substituting the values of nh is equal to. The step 5 is substituting values of nh is equal to 5. Okay. Now here, see, before substituting, let me take here, see, n into h here, again n into h. Let me write down that first. So nh plus here 1 nh, another h I am going to multiply inside, nh minus h. I hope you are getting this one. Okay. Now substituting the values, you are getting limit as s tending to a 0, nh value is nothing but 5 plus 5 into 5 minus h divided by 2. Now next is nothing but you are going to substitute h is equal to 0. Substituting h is equals to 0, you are getting limit as h tending to a 0, you are getting as 5 plus 5 into 5 minus 0 divided by 2. So the answer you are going to get for this one, which implies that 5 plus 5 minus 0 is 5, 5 5s are 25 divided by 2. So the answer you are going to get 5 2s are 10 plus 25 divided by 2. 10 plus 25 divided by 2 is nothing but, which implies 35 divided by 2. And this is your final answer. You are going to get it as dear students. I hope you understood these steps also. Now we'll be moving on to the next problem, dears. What they have asked, integrate 2 to 3x squared into dx as a limit of a sum. Now here, let me take it as, see, formula you know already, but I am going to write it once. A to b f of x into dx is equal to limit as n tends to a infinity, h tending to a 0, h into f of a plus f of a plus h plus etc. plus f of a plus n minus 1 into h. Okay, now you are having what is h is equal to b minus a divided by n. Cross multiplying nh is equal to b minus a. So b minus a, you know, b is nothing but 3 and a is nothing but this is b and this is a. So 3 minus 2 which is equal to 1. So nh I can substitute directly is equal to 1. Are you getting? Now here let me take that one first. First step is what? Substituting x is equal to a plus h etc. a plus n minus 1 into h, right? So step 1, put x is equal to a comma a plus h, a plus etc. a plus n minus 1 into h, right? Substituting those. Now step 2 is nothing but, this is step 1. Step 2 is nothing but finding out f of x. F of x is there, they have given x squared. So x squared and substituting the value. So f of a, what is a? A value is nothing but 2. So let me substitute directly. F of a is nothing but 2 only, right? So therefore you can substitute here 2 plus h, 2 plus n minus 1 into h. So therefore let me write it here, which implies 2 comma 2 plus h etc. 2 plus n minus 1 into h. I hope you are getting. Substitute the value of a is equal to 2 there. That's it. Now f of 2 will be is equal to 2 squared, which is 4. Again f of 2 plus h is nothing but what? 2 plus h whole squared. You can expand this one, right? Which is nothing but 2 squared 4 plus h squared plus 2 into 2h, which is 4h, right? Similarly, you can have etc. f of n minus 1 into h, which is f of 2 plus n minus 1 into h, which is nothing but 2 plus n minus 1 into h whole squared, right? Because x squared. Now expanding that, you are going to get it as 2 squared, which is 4, n minus 1 into h whole squared, which is n minus 1 whole squared into h squared, plus 2 into n minus 1 into h, which is 4 into n minus 1 into h. Are you getting this one? So now substituting these values in the formula, you are going to get it as, that is a step 3, substituting the values, limit as n tends to a infinity, h tending to a 0, you are getting h into f of a is nothing but 4 plus 2 plus h is nothing but 4 plus h squared, that is I can write 4h plus h squared plus etc. plus you are having plus 4 plus 4 into n minus 1 into h plus n minus 1 whole squared into h squared. I hope you are getting this one. Now here ds you can observe 4 how many times? 4, 4, now again 4, right? How many times of 4? There are n times of 4. So therefore you can write it as, which will be is equal to limit as n tends to a infinity, h tending to a 0, you can write h into n times of 4, that is 4n you can write if you want, plus see here I am taking here as 4h, 4 common factor. If I take 4 common factor, you can get it as h plus 2h, because you are going to get 2 plus 2h. If I am going to expand, I am going to get it as there 8h, isn't it? So therefore you can get it. See, if you want, you can expand 2 plus 2h whole square, which is nothing but 4 plus 2h whole square plus 2 into 2h, right? So which you are getting it as 4 plus 4h squared plus 8h, right? See, you are going to get 8h there. So therefore I can have here, it will be is equal to, see, if I take 4 common factor, you are getting it as 1 plus 2 plus 3 plus etc. plus here you can have n minus 1. See here n minus 1. Okay. So dear students, if you take it as here h squared common, which can be written as 1 squared. Again if you take h squared common, which can be written as a 2 squared, isn't it? So therefore you can take plus h squared common, 1 squared plus 2 squared plus 3 squared plus etc. plus here n minus 1 into h squared. H squared already taken common. That's it. I hope you are getting this step. Now we'll be moving on to the next one, which implies integral. What is that? They have given the problem 2 to 3. F of x is nothing but x squared into dx, which will be is equal to limit as n tending to a infinity, h tending to a 0. You are getting h into 4 times of n plus, now you can substitute here 4 into n minus 1 divided by 2, you know the formula. Similarly, dear students, according to mathematical induction, 1 squared plus 2 squared plus 3 squared plus n minus 1 whole squared. So here n minus 1 whole squared is there. So that is given by the formula plus h squared into n minus 1 into 2n minus 1 divided by 6. So this formula you have to remember, which is 1 squared plus 2 squared plus 3 squared plus etc. n minus 1 whole squared according to the mathematical induction. Got? So now multiplying h inside. So what happens? Limit as n tending to a infinity, h tending to a 0, 4nh. I am multiplying this h inside all the way. So now nh into nh minus 1. So therefore you are getting, so sorry, here 4h is there. I forgot to write. See, 4h is there. 4h only I have to take common. Then you can have 4 plus here h will be included. So 4h into h. See, this h I am going to multiply with n, 4nh, and this h I am going to multiply with this one. So nh minus 1, okay, divided by 2. I hope you are getting this one. Now plus again 2h are there. One more h will be here, which will become h cube. So I am going to multiply in each. One h here, nh, another h here, nh minus h, another h is here. That is 2nh minus h. Okay. So divided by 6. I hope you are getting this one. Now next, here substituting what? nh is equal to. What is the nh is equal to? You know nh is equal to is nothing but 1. So therefore, which implies limit as h tending to a 0, 4 into 1 plus 4 into 1 into 1 minus 1 divided by 2. This h will be multiplied here, right? Because this h will be multiplied here, this h will be. So 1 minus h divided by 2 plus here nh is nothing but 1 into 1 minus h into 2 into 1 minus h divided by 6. Now you can have, which implies limit as h tending to a 0, substituting the value of h is equal to 0 there. So 4 into 1 is 4 plus, so 2 1s are 2 2s are. Now here 1 minus 0, right, into 2 plus, again you are having 1 minus 0 into 2 minus 0 divided by 6. Now which will happen? The answer will be implying that 4 plus 2 into 1 minus 0 is 2 plus 1 minus 0 into 2 minus 0 is 1 into 2, 2 divided by 6. Now you can have 2 1s are, 2 3s are, 1 by 3. So therefore, the final answer you are going to get it as 4 plus 2 plus 1 by 3. Now 4 plus 2 is nothing but 6 plus 1 by 3. 6 plus 1 by 3. So the answer you are going to get 3 6 are 18. 18 plus 1 is 19 divided by 3. And this is your final answer you are going to get for this question, DS. I hope you understood these steps. Now we'll be moving on to the next problem, what they have asked. Integrate minus 1 to 1 e power x into dx as a limit of a sum. Now here, let me moving on to the formula, which is integral a to b f of x into dx is equal to limit as n tending to a infinity, h tending to a 0, h into f of a plus f of a plus h plus etc. plus f of a plus n minus 1 into h, right? Now here, step 1 is what? Step 1, first let me find out what is b minus a. Now you are having b is nothing but this and a is nothing but this. So nh is equal to b minus a. So which will be b is 1 minus of minus 1 which is 1 plus 1 is equal to 2. So NH is equal to 2. This you need to remember. Now here step 1 is nothing but you are taking, put x is equal to, a value is minus 1. So minus x is equal to minus 1, comma minus 1 plus h, etc. minus 1 plus n minus 1 into h. This you are going to substitute because a value is minus 1. So this you need to substitute because a value is minus 1. Now next, you are going to do step 2, substituting the value in f of x. You know f of x is given by e power x. Now therefore, f of minus 1 is nothing but e power minus 1. F of minus 1 plus h is nothing but e power minus 1 plus h, which can be written as e power minus 1 into e power h. Again, f of minus 1 plus n minus 1 into h is nothing but e power minus 1 plus n minus 1 into h, which can be written as e power minus 1 into e power n minus 1 into h, which also can be written as e power minus 1 e power nh into e power minus h. I hope you are getting this one. Okay. Now next, substituting that in the formula, you are getting step 3 is substituting in the formula limit as tending to a infinity, h tends to a 0. Now you are getting f of a, which is e power minus 1 plus h is e power minus 1 into e power h plus etc. plus e power minus 1 into e power nh into e power minus h. Okay. So therefore, you can have this will be is equal to, because h will be multiplied there. Now you can take how many e power minus 1 is there? 1 term, 2 term, up to n terms of e power minus 1 is there. Now dear students, you can have this terms is in GP, that is AR squared, which is e power 2h, AR to the power of n minus 1, isn't it? So therefore, this is, you can write it as, see, this I am going to combine as it is. So here I am going to write it as, instead of this only I am writing e power minus 1 e power n minus 1 into h. Why? Because this is in the form of GP, AR squared, AR to the power of n, isn't it? Which form a GP? So this form a GP. Form a GP. GP means what? Geometric progression. What is the sum to n terms of GP? Sum to n terms of GP, is nothing but you are going to have if r is greater than 1, okay, which is given by a into r to the power of n minus 1 divided by r minus 1. So therefore here a is nothing but e power minus 1 and r is nothing but e power h. Therefore, substituting accordingly, which implies integral of minus 1 to 1 e power x into dx is nothing but limit as n tending to a infinity, h tending to a 0, h into a e power minus 1 into e power nh minus 1 divided by e power h minus 1. I hope you are getting this one. E power h is nothing but r. So r to the power of n minus 1. E power h is nothing but r. So r to the power of n, which is e power nh minus 1 divided by e power n minus 1. Now close the bracket. Now here I am going to multiply that h inside. So therefore, and substituting nh value. nh value is nothing but 2. So limit as h tending to a 0 e power minus 1 into h into e power 2 minus 1, substituting nh as 2 divided by e power h minus 1. Now here this e power minus 1 and e squared minus 1 is a constant. So e power minus 1 into e squared minus 1, limit as h tending to a 0, you can have h divided by, remaining is h only, divided by e power h minus 1. Dear students, according to the exponential form, limit as theta tending to a 0, theta divided by e power theta minus 1 is nothing but 1. So therefore limit, instead of theta we are having a h. So therefore you can have e power minus 1 into e squared minus 1. This will become limit as h tending to a 0 constant. H tending to a constant is nothing but constant only. So therefore e power minus 1 into e squared minus 1 into 1. So the answer is e power minus 1 into e squared minus 1. E power minus 1 you can bring it to down. So e squared minus 1 divided by e, because 1 by e is nothing but e power minus 1. Otherwise the final answer e squared by e is e minus 1 by e. So that is your final answer. You are going to get it as dear students. So dear students, I hope you understood all the problems in this what and all I have solved as a limit of a sum. Still 2 problems you can try it over based on what I have taught now. Please do remember the formula and step-by-step explanation. That is very important dear students. So keep watching. Thank you. Have a nice day.